So for those that actually watched the word example on the CEMC website that I recommended for you to watch, they gave a word problem where they actually worked with a decay, where something was actually decaying by a certain rate. So in this video, we're going to do a growth question. So you got $100 and you're going to invest it, and apparently it grows 25% every day. All right, this is a makeup question, may not exist in real life. So when it's 25%, all right, so when I mean by 25%, I mean 25% of its previous value. So let's just say on day one I made 25% of 100. What that means is I would have an additional 125 because you multiply by 25. And the next day, the 25% is off of the previous amount. So you would take this number here and also multiply by 0.25 and get that brand new number, all right? So in this case, you're always multiplying by what number to get from one to the other. In this case, 1.25 and 1.25, because you want to keep the original amount from before. So in this case, we're always multiplying by 1.25 from 100. So for part A, all right, at what rate is your money growing at day 3? So we're going to have to find a model for this, an equation for this situation. So going back, I'm going to write down A, B, X. Other teachers may have used different letters, but A is the initial amount and B is the how something is changing, and X is the number of changes, number of periods. And in this case, let's let A be the $100. And we know that to get from one to the other, from one day to the next, you're going to multiply by 1.25, all right? Keep in mind, this is a growth. If you actually did this, 0.25, if you to graph this out, this number is going to get smaller. So that's why when the rate is greater than 1, when you multiply something greater than 1, it's going to grow to the power of, we'll call it x in this case. Let's x be the number of days and y be the amount of money that you have. So this is your model. First question's asking, at what rate is your money growing at day 3? So the rate means you want to find how fast something is changing. In other words, the slope. So in order to find the slope, you're going to have to figure out the derivative of this function here. So in this case, we're going to take the derivative. 100 is a constant that you just leave it out. Then you have 1.25 to the x as is, but you need to figure out that ln piece right there. And so this is our derivative function. Now the next thing you're going to do is, well, what happens after 3 days? So over here, I'm just going to use Leibniz notation just to bring it back. So we want x to be equal to 3. In other words, you're going to take your answer here, your function here, derivative function, and sub in for 3. I think I did something wrong. Ooh, over here, that's 1.25 to the power of 3. So in the next question, AA here, how much money will you have after 3 days? So what is this question really asking for? Is it asking you for the rate of change, or how fast your money is growing, or is it actually asking you for the actual amount? In this case, it's actually asking for the actual amount, meaning which function will you be using, the rate of change equation or the original equation? And in this case, we're going to use the original equation. So the idea of this question is, well, which function are you going to substitute in or work with, either this or this one here? In this case, for AA, we're just going to directly substitute 3 into the original function, the model function. All right, so part B. Part B says, which day will you have $300? So $300 is the y value, it's the amount. So you're going to substitute 300 into the y value and solve this exponential equation. So I'm going to divide both sides by 100. That gives me 3, 1.25x. And then this is exponential form. We can change it to a log form, or you can log both sides. You can ln both sides. Let's actually do something different. Let's actually ln both sides, natural log. So I'm going to take the natural log of 3 on both sides, natural log of 3 to the x. Then I'm going to use the power rule, bring the x down. And then we isolate for x by dividing both sides by ln 1.23, and we end up getting x being ln 3 divided by ln 1.25. Put in your calculator and you get some value after that. So in the next question, part C, what is it asking for? What day, meaning you're going to be solving for the x, will the money increase by a certain rate? So if you notice the units, this is a rate unit, 1.5 or $1.50 per day. So that means 150 is actually equal to your y prime. It is the slope, it is the rate. So we're going to substitute 1.5 into the y prime. So 1.5 is equals to 100 ln 1.25 times 1.25 and x. So this is another solving for exponential equation. You divide both sides by the constant, so 1.5 divided by 100 ln 1.25. So this massive thing is just a number. You can just put in your calculator. And the rest here, last example we used ln. Now let's actually go directly into log forms. In this case, x is equals to log base 1.25, and I'm going to put this big circle. That actually means this, all right? And some people have that special log button on their calculator, and if you didn't have that special log button on your calculator, then you can just change the base to a base of 10, this massive thing here, and then log 1.25, and then you'll get your number at the end. So over here, I just wrote down what happens every day when you invest or you make 25% of your previous day. So this is what happens. So basically, you're going to multiply everything by 1.25, 1.25, 1.25 to get to the next day. And that's how we got the equation y is equals to 100, 1.25 to the x. Well, I'll use x here. That should be that. All right. And in this question, things don't have to happen every day. In this case, every 4 days. So how would your equation change? So basically what's happened is that this table wouldn't change much. This one will not change. The dollar sign, it is this that will change because something's happening every 4 days. In other words, this is going to be 4 days. This is going to be another 4 days, 8, and this is 12. Right? So if the table of values changes, that means your equation has to change to some degree. And it's going to be the input that changes. So it's no longer x, is going to be a different input variable or an input term, right? So you have a choice. It's either 4x or x over 4, or something to do with 4, because something's happening every 4 days. Now, in our case, it's going to be over 4. And how can we test it out is you can take the 4 and sub this into here directly and see whether you get 125. Same thing for 8, same thing for 12. So one way you can check your model is take the values, sub it in to see if the model fits. In this case, the model does fit. Now, some students might do this, 100, 1.25, and they put 4x. Okay, if you put 4x, well, if you sub in 4 days into here, you would get 100, 1.25 to the power of 16. And that is not going to give you 125. So just be aware of that. So basically, if something happened every week, well, every week means every 7 days. So your model is going to be 100, 1.25 to the power x divided by 7. Something's happening every 7 days. Now, that's assuming that x is days. Some of you might wonder, well, if I don't want it to be in days, I want it to be in weeks, then you can have to redefine your variables. So in this case, you can let 100, 1.25 to the power of x, but you have to tell me or write down what x means. In this case, x is the number of days for the first part here, but in this particular example, x is the number of weeks. So just be aware of the units that you use when you define your variables.